Okay, now this function, when you've got x surrounded by these thick brackets like this, that's called the greatest integer function. And when you plug a value for x in, it always returns the greatest integer that's less than or equal to x. So if you plug 0 in, the greatest integer less than or equal to 0 is 0. But if you plug 0.1 in, the greatest integer less than or equal to 0.1 is 0. Same for 0.2, you get 0. If you plug 0.3 in, you get 0. 0.5, you get 0. 0.6, 0.7, 0.8, 0.9, you still get 0. 0.99, you get 0. But then when you get to 1, it jumps to 1. So if you plug a 1 in, the output is 1. And if you plug 1 point anything in, 1.2, 3, 4, 5, 6, 7, 8, 9, or 1.99, it's still going to be 1. But once you hit 2, then it jumps up here to 2, and so forth. So again, this is the greatest integer function. And let me show you it on the graphing tool here. And you can see right here, anything from 0 to 1, you're going to get 0. Anything from 1 to, but not including 2, you're going to get 1. And from 2 to 2.999, you're going to get 2, and so forth. So that's what that function looks like. Now, a piecewise function has 2 or more pieces, or it's 2 or more functions in one. So in this example, you've got 2 functions, f of x equals 3 and f of x equals 2x minus 1. And the function actually changes at some value. So in this case, the function changes at x equals 2. So basically, if you plug in any number less than 2, like -2 or 0, you get this function 3. So when x is -2, you get 3. When x is 0, you get 3. Or even when x is 1, you get 3. But once you get to 2, you would plug into this function, because this function, 2x minus 1, use that function if x is greater than or equal to 2. So any numbers like 2 or greater than, you plug into this function. So if x is 2, you get 2 times 2 minus 1, which is 3. If x was 4, you would get 2 times 4 minus 1, which is 7. And if x is 6, you get 2 times 6 minus 1, which is 11, and so forth. So you can see that this function would actually break right here at x equals 2. So let me slide that over a little bit. So that's where it breaks. And so to the left of x equals 2, you get the constant function here, y equals 3, or f of x equals 3. And then to the right of 2, you get the linear function 2x minus 1 right here. And so that's what that piecewise function looks like. Now this other piecewise function, it breaks at x equals 0, which would be the y-axis. So to the left of the y-axis, in other words, when x is less than 0, you get the absolute value function. Now if you remember, the absolute value function looks something like this. You go down here, and then you come up here, and you get something like that. Okay, but we only get the absolute value function to the left of 0. So we only get the piece that's on this side. Okay? Now, what do we get to the right of 0? Well, to the right of 0, we get the parabola y equals x squared. So to the right of 0, you would get half of that parabola right there. So that's half of y equals x squared. So this function changes at x equals 0. So it changes from the absolute value function, and then at 0 it changes over to the x squared function. Okay, and so that's basically all I have to say about piecewise functions. You could have actually 3 pieces. Like I could have it to the left of 0. It could be absolute value of x, and then say from 0 to 2 I could have x squared, and then say from greater than 2 I could have another function. But right now I just want to worry about with 2 functions in the piecewise function definition. And that's pretty much it on the graphing